But what they both come down to is your ability to break things apart and figure out what has to be added in, what has to be subtracted out, and what's part of the area, what's not. So looking at number 1 over here, we have 3 shapes basically. We have a rectangle down here, we have a rectangle up here, and then we have this corner piece. Well, rectangle number 1 is, of course, there's a dimension missing here that might have made this a little easier for you. Rectangle number 1 is 16 inches by 8 inches, which makes that 128 square inches. Rectangle number 2 is 12 inches by 8 inches, making that 96 square inches. So now all we need to find is the area of this corner piece. Well, that corner piece is part of a larger quarter circle. That quarter circle, well, the distance from here to here is 24 minus 12, or 12 inches. The distance from here to here is 28 minus 16, which is also 12 inches. Have the same distance in both directions, which confirms that that is a true quarter circle, that it's a radius. So that is a quarter circle with a radius of 12 inches. So that area will be pi times 12 squared, and then, of course, divided by 4, because it's a quarter circle. It's a fourth of a circle. 3.14 times 12 squared divided by 4 should be 113.04, and it is. I'm going to do this. 113.04 square inches. But that's the whole thing in tan there. We only want the green part, which means this purple section has to be subtracted out. Well, that's also a quarter circle, since it is 8 inches in both directions here. It was 12 inches for the whole radius, so minus 8. This is a 4-inch radius here. So that area is pi times 4 squared divided by 4, because it's a quarter circle. That would be 12.56 square inches. We can subtract that now to get 100.48 square inches. So that goes up here. That's our third piece. 100.48 square inches. That adds up to 324.48 square inches. Is our total area for that. Anybody get that one correct? Show of hands. 1 or 2? Okay. That is a tougher problem. Now, the way we did this corner piece here, I think is the simplest way to approach it, because we made it just 2 quarter circles and subtracted them out. But there is another method. You can actually use diameter. So if it's an 8-inch radius, it'd be a 16-inch diameter. Then divided by 4, because it's a quarter of that full circle. That's 12.56 inches. So the length of that arc, the center of that corner piece, is 12.56 inches.
White navy beans and 2 bags.
8 inches. Somebody's got their microphone on. If I can get you to mute it for us. So our width is 8 inches. We could have done that average arc length times that width of 8 inches, which actually does come up to 100.48 square inches. To me, that version is actually quite confusing to me. I think it's a lot simpler to do the 2 quarter circles and subtract the smaller one from the bigger one. Okay, let's go over to problem number 2 here, the surface area. Start out here, we're going to find the surface area of that large cylinder in blue there. Like we did yesterday, we have the large circles on the end. The area of those is pi times 8 squared. The diameter is 16. The radius is 8. Pi times radius. So then we have, what's pi times 8 squared is 200.96, I believe, square inches. And there's 2 of them. There's one on the other end as well. Now we talked then about the area, the lateral area of the cylinder. That's this part that wraps around here and goes between the circular ends. And we talked about it being basically a piece of paper that's rolled up. And we can slice it down the side, unroll it. The height is still the height of the cylinder. The length is the circumference of that circular end. That'd be the circumference around this end here. Well, that circumference is pi times 16, which is what, 50.24 inches, times that 30-inch length or height, however you want to look at it. That gives us 1,500 and what, 7.20 square inches. Let's add all that up for now. 12, carry the 1, 19, 21, carry the 2, 9, 0, 9. So 1,909.12 square inches. That's if this were just the big cylinder. But we've got that little cylinder cut out of the middle of this. So now we've got to work with that little cylinder and figure out what parts do we cut out and what adds in. Well, the little circles here, these little circles are missing. They are cut out, so we do have to take those out. If this is 4 inches here and 4 inches up here, away from the 16 leaves us an 8-inch diameter in the middle here, which means the area of that circle is pi times radius, which would be half of the 8, or 4 squared. Pi times 4 squared is 25.12. Well, there's one on the other end as well, 25.12, and those are both being subtracted. Also, what does that come out to be? 184, 1884, 1858.88, I believe, square inches. So that's where we're at after we cut out those circles. Next, we have this sleeve down through the middle here, this portion. It's kind of it's basically like the outside of our cylinder, but it's on the inside. Well, that area is going to be a rectangle just like the outside was. It's going to have that height of 30. Its length is going to be the distance around this smaller circle. So that would be pi times, that circumference would be pi times 8, or 25.12 inches, times that 30 inches of length. So that's going to be what, 753.6 inches? Square inches, which adds up to be 2,612.48 square inches of surface area. Now, that's not a problem I would expect you to do quite yet on a test or a quiz, but it's a great exercise in trying to figure out what is included, what is not included, what do you take out, what do you add in. It's really a good exercise to get used to that, of knowing what pieces have to be subtracted from the total and what pieces have to be added in. Because that one, it's not horribly complex, but there's a lot going on there. Anybody have any questions off of those two problems? Okay, anybody have any questions off the homework from yesterday? Don't forget, you do have a quiz out there from yesterday. I noticed that many of you still haven't done that yet. So make sure if you have not completed that yet, make sure you get that done right away and turn that in. We don't want to get too far behind on our quizzes because they do come up pretty fast here in this section. Okay, so today we want to continue on with our geometry. And we want to continue, actually, today we're going to focus in on triangles. And we're going to start out with right triangles. Well, when we make a right triangle, that little symbol, that box in the corner, is a square. That signifies that that's a square corner. That's our right angle. The two sides that come together to make the right angle are called legs. So that's a leg, and that's a leg. Our other side, the one that's across from the right angle, is called the hypotenuse. The hypotenuse is always the largest side. There is no way that a leg can be larger than the hypotenuse. Well, there's a relationship if we label our legs A and B and our hypotenuse side C. There's a relationship between those sides that pretty much all of us have seen at one point or another. It's called the Pythagorean rule, or often the Pythagorean theorem. And it says simply that if I take the length of the first leg and I square it, and I add it to the length of the second leg squared, that total adds up to the length of the hypotenuse squared. I'll do a little better than that. So if I have a right triangle here where I have 6 feet, 8 feet, and 10 feet. My legs are the 8-foot and the 6-foot side, so I'm going to call those A and B. My hypotenuse has to be the 10-foot side. That's across from the right angle. So A would be 6 feet, so that's 6 squared. B is going to be 8, so that's 8 squared. Has to equal C is 10, so that is 10 squared. Now it's just a little bit of order of operations. 6 squared is 36. 8 squared is 64. 10 squared is 100. And our 36 and 64 do add up to 100. So that confirms that that is a right triangle. And that's one of the things we can use this Pythagorean theorem for, is to check to see if a triangle truly is a right triangle. If I have something like this, or say this is 11 inches, this is 25 inches, and 27 inches, if I want to see if this is a right triangle, usually it's easiest for me to pick out the hypotenuse. The longest side here is the 27. If this is a right triangle, that would have to be the hypotenuse. So then my other two sides of the legs, I'm going to call them A and B. It doesn't really matter which one's which. A squared plus B squared equals C squared. A is going to be 11, so that'll be 11 squared. B would be the 25, that's 25 squared, equals C will be 27, so that's 27 squared. 11 squared is 121. 25 squared is 625. 27 squared, oh, what is that? 729, I believe.
Recording is on.
Yeah, 27 squared is 729. Well, if I add up here, my 121 and my 625, I get 746. Those are not the same. This is not a right triangle because those don't add up. The other thing we can use this Pythagorean theorem or Pythagorean rule for is if we do know that it's a right triangle, we can find the missing side. So if I tell you that that's a right angle, I tell you this is 5 inches, this is 12 inches, and I ask you to find that other side, we can find it. Now, first of all, the 5 and 12 are the legs, so I'm going to call them A and B. And X is the hypotenuse, so I'll call that C. A squared plus B squared equals C squared again. And we plug in our numbers. A is going to be 5, so that'll be 5 squared, plus B is 12, so that's 12 squared, equals D is going to be our X, so that's X squared. Now it's a matter of doing order of operations again. 5 squared is 25, plus 12 squared is 144. At this point, we can't do anything with the x squared yet, so we'll just leave that as x squared. 25 and 144 is 169 equals x squared. Now, if x squared is 169, x has to be the square root of that. Square root of 169 is 13. X is 13. Those other measurements are in inches, so that is 13 inches. Well, that was if we were looking for the hypotenuse and we knew both legs. Sometimes we know the hypotenuse, and what we're looking for is one of the legs. Situation like this. So I'm going to call my missing leg A, my other leg side B, and my hypotenuse is still side C. Excuse me. So we have A squared plus B squared equals C squared. And we'll fill in our numbers. A is going to be the missing side X, that's X squared, plus B is 8, so that's 8 squared, equals C is 17, so that is 17 squared. Nothing we can do with the x squared quite yet. 64, or 8 squared is 64, equals 17 squared is 289. Now to find x here, I have to get it by itself. So I'm going to subtract 64. Get that x squared is 215, or 225, I should say. And if x squared is 225, x has to be the square root of that. X will be 15. So this is 15, and my units being used are feet, so that'll be 15 feet. Now remember, we talked about finding the area of right triangles. And when we talk about finding area, we have to multiply two dimensions that are perpendicular, or at right angles to each other. So for this triangle, those two dimensions are going to be the 15 and the 8. The area here is going to be 8 feet times 15 feet divided by 2, giving us 60 square feet. It's always the two legs that make the right angle, so it's always the two legs that we're going to use to find our area. So if I tell you that I have a triangle where side A is 9 inches and side B is 41 inches, I ask you to find the area. So side A is 9 inches, side C is 41. We do not know side B. To find the area, we would use the two legs, sides A and B. So I have to find side B. A squared plus B squared equals C squared. A is 9, so that's 9 squared, plus B squared equals 41 squared. And now we got to figure out what b is. Well, 9 squared is 81. Not going to do anything with the b squared yet. 41 squared is 1,681. So we will subtract the 81. Get that b squared is 1,600. And we'll square root. Get b is 40. So b is 40 inches. Well, we'll still need to find the area. So that area is a of 9 inches times b of 40 inches divided by 2, 180 square inches. Well, what if we don't have a right triangle? We looked at some yesterday where we didn't have a right triangle, but we had an altitude. What if we don't have an altitude? What if we have all 3 sides? I want to find the area of a triangle from the 3 sides. Let's take a triangle like this. Let's say that this is 12 inches, 16 inches, and 20 inches in length. Well, a Greek mathematician by the name of Huron invented something called Huron's formula, sometimes referred to as simply Hero's formula, for finding the area of a triangle from just its sides. So he used the perimeter. P is found by just adding up the sides. What is that? 48 inches is the perimeter. And then Huron defines something called the semi-perimeter, labeled with an S. That's just the perimeter divided by 2. 48 inches divided by 2 inches, or divided by 2 is 24 inches. That's our semi-perimeter. From that information, if we called the sides A, B, and C, none of them are hypotenuse or legs because it's not a right triangle, but we can still label the sides A, B, and C. Usually you go smallest to largest, A, B, C, like that. The area of that triangle could be found by doing the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. So now we got to put some numbers in there. Semi-perimeter is 24. 24 minus the furthest side is 12. 24 minus the next side would be 16, and 24 minus 20. Now to make this easier in the calculator, I've got 24 here. 24 minus 12 is 12. 24 minus 16 is 8. And 24 minus 20 is 4. So let's calculate that out. Square root of 24 times 12 times 8 times 4 gives us 96. That area is 96. The lengths are all in inches, so that'll be in square inches. Now that worked because this is actually a right triangle. I cheated a little bit. If it weren't a right triangle, that'll never come out to a nice, neat little number like that. If it's not a right triangle, it actually comes out to what they call a non-terminating decimal. It goes on forever. Let's do an example. Let's do 11 inches here, 17 inches, and 20 inches. And let's find our area. Well, our perimeter, 11 plus 17 plus 20 is, well, once again, that's 48 inches. I didn't plan that, it just worked out. So our semi-perimeter is 48 inches divided by 2. 24 inches. So our area is that semi-perimeter 24 times 24 minus 11 times 24 minus 17 times 24 minus 20. 24 minus 11 is 13, 24 minus 17 is 7, and 24 minus 20 is 4. So this is the square root of 24 times 13 times 7 times 4. 93.47, we'll call it. So our area comes out to be 93.47 square inches. Handy little formula to have. In construction, there's a lot of times we run into stuff where we're not sure if it's a right triangle. We can still find its area using that. In surveying, it comes up a lot as far as laying out lot sizes and stuff like that. We can find those missing dimensions. Our homework for today. There is a packet in Blackboard it's posted under week 5, September 23rd. And in that packet, it is pages 144 through 147. The homework is in the gray boxes. Keep this packet handy, save it on your computer or whatever. We're going to use this packet off and on for homework over the next several weeks. There's a lot of assignments in this packet. Okay, that is all we have for material for today. If you want to start on the homework,